Pythons are overrated. Yeah, okay. Is anybody in the stream before I start? Is anybody actually very experienced with Python? I'm guessing at least a few of you are just here curious to see about the book and maybe how little I know. Okay, cool. The next step is for Andy to get the book. Yeah, Andy and I are so in sync. For those who don't know, Andy Laptoff, he's part of the podcast that I do called The Art of Network Engineering. Andy and I are so similar in this way. We have both been network engineers, traditional network engineers. We've been super resistant to learning coding. But now I'm pretty sure Andy has eclipsed me in knowledge on this subject because I think it's part of his job now is to know some of this stuff. So I should really be learning from him, shouldn't I? He might hate me for saying that. I'm not sure. Okay, so we have some intermediate people. We've got, a little bit of Python here and there, familiarity. Okay, cool. So no self-proclaimed experts yet. That's good because otherwise you're going to laugh at me real hard. Okay, so Mastering Python Networking 4th edition. Also, shout out to Eric. He just provided me with the PDF. But if you purchase the physical copy of the book, something that I love is, and I don't know if this is Eric's choice or the publisher's, but something that I love about this is that you can get a free copy of the PDF if you do buy the physical book. Oh, I'll go into this in just a moment. There is a community. However, where the hell did it go? Second, did I miss it? Zoom out real quick and just table of contents. The most fun part of a book. Yeah, you know what? I'll find it. Anyway, there's a part of this book where you get, here we go, there we go. It's past where I thought it was. So, okay, so if you buy the book, you can download a free copy, a free PDF copy of it. Love that because I'm always on a different machine. Like, also I like to stream when I'm learning stuff. So it's super helpful. So you can just basically, if you buy it, you get your own free PDF copy. So shout out to Eric and or publisher for this. Thank you. Okay, and there's something else I wanted to touch on. So here is, let's see if you can take a look before I start. Here is the link to the book community. So I would like to, I'm also going to post in the chat in just a moment. I'm going to post a link that I want to say this one is the same, but I haven't followed this one. I'm going to post a link right now that you can follow to sign up for the community around the book and around learning automation in general, especially from like a networking point of view. Sign up there. It's basically like a forum. You can talk with the author of this book and share feedback. You can talk about your automation journey. You can learn from other people who are working on it as well. So he's got a great community here. If you are interested, I encourage you to sign up. I am there myself, although I haven't posted because I'm just starting out, right? So anyway, here we go. I'm not going to read the preface. Although, you know what I am going to say? I am going to read this part. Who this book is for is kind of important, right? This book is ideal for IT professionals and operations engineers who already manage groups of network devices and would like to expand their knowledge of using Python and other tools to overcome network challenges. Basic knowledge of networking and Python is recommended. Now, I don't think you absolutely have to have the Python knowledge because I may have skipped ahead a little bit and read some in this book already, just a little bit. And he explains things pretty well to introduce you to Python. So I would say if you're a network engineer and you're interested in automation, you have a little bit of an idea of how it could help you, then you're the target audience. You're good to go. To get the most out of this book, some basic hands-on network operation knowledge and Python knowledge is recommended. As he stated before, most of the chapters can be read in any order except for chapter 4 and chapter 5, yada, yada, yada. So that introduces base technologies we're going to use later. Besides the basic software and hardware tools that are introduced at the beginning of the book, new tools relevant to each of the chapters will be introduced in their respective chapters. So we go step by step, it seems like, which is, in my opinion, a good way to go about it. Okay. So eventually this is going to involve stuff where you can like actually use some of this in your own lab at home. So I'm actually pretty excited because I'm getting my home lab like set up now, right? Yeah, if you know any programming, it's not hard to move from one language to another. I hope that's true. I feel like, yeah, I mean, the logic behind programming is typically pretty similar, right? It's just a matter of the syntax and some more abstract or advanced concepts. Okay. Here we go. The best part of having a PDF copy is scrolling through on stream. All right. So our first chapter. This is where we do our introduction. So everybody get cozy. All right. This is going to be like a bedtime story. This is literally, I'm so sorry. This is my content for Twitch, okay? This is my streaming content is me reading out of a book. So everybody get cozy, get your blankets, get a cup of tea, get a cookie, whatever you want. I don't know what time it is where you are right now. It's like a little after 5:30 p.m. my time. So I know in like down under, I've been told a few times now that it's like 2 a.m. in Australia or whatever. So if you if you're here, Australia, New Zealand, Oceania, like thank you first of all, and everybody get cozy because this is a Python bedtime story essentially that I'm reading you. All right. Hashtag pro streamer content. Yeah. Oh, in France it's 2:40. Hey, maybe I misunderstood. I'm gonna stop pretending I understand time zones off the top of my head. Maybe it was France or like European time zone that I was hearing. It was 2 a.m., not Australia. Yeah, in Australia, it's definitely already Sunday, but I don't know. Okay. So, okay, in Australia, Sydney, Melbourne, okay, so y'all are already like well into the day. You are not going to sleep. You've already slept and woken up, and it is Sunday. Mother's Day. Happy Mother's Day, by the way, for everyone who is celebrating on Sunday. I actually can't remember if this is a US specific day for the holiday or if it's international. Okay. Yeah. All right. So Europe, basically. Europe and like, I don't know, East Coast maybe if you're going to bed kind of early. East Coast of the US, Europe, the Atlantic Ocean, if you're anywhere in there. Get cozy. Get a blanket. You know. Welcome to the new and exciting age of network engineering. I'm really sorry. I have to stop right there. Look at that exclamation mark. Thanks, Eric. Thanks for the enthusiasm. Because I'm pretty sure a lot of us would be so jaded now that we would just say that completely sarcastically. Okay, in the UK, Mother's Day is in March. I apologize then. Mother's Day. Interesting. I could have sworn someone told me that in Australia, New Zealand area, Mother's Day is also on Sunday, May 14th this year, but yeah, okay. A bot task. Yeah, Mr. Hamill, can you just write me all the bots? I'm just kidding. Actually, that's something I should learn how to do with this book, right? Just kidding. Don't. Nope. What is that saying? Necessity is the mother of innovation. I don't know. You get what I mean. When you really desperately need something, you find a way to get it, right? That's what I have to do with Python. The mother of invention. Thanks. I was close. Invention, innovation, they're close. Right? That's chapter 2 is writing the bots. Okay. Are we implying that an exclamation point can't be sarcastic? You know what? That's fair. The exclamation point, this sentence right here, it could be sarcasm. It definitely could. But I know Eric a little bit, and he is such a positive, like true, honest person. I can see that my feeling is that this is not sarcasm, but it would be hilarious if it were. Either way, thanks, Eric. I appreciate the enthusiasm here. All right, so this is from Eric's point of view, right? So when I started working as a network engineer at the turn of the millennium, some 20 years ago, that makes us all feel super, super old. That makes me feel super old. The role was distinctly different than the network engineering role of today. At the time, network engineers mainly possessed domain-specific knowledge to manage and operate local and wide area networks using the command line interface. While they might occasionally cross over the discipline wall to handle tasks normally associated with systems administration and developers, there was no explicit expectation for a network engineer to write code or understand programming concepts. This is no longer the case today. Let me just say, this is the first time in a while that I've wished I was born, I don't know, 20 years earlier, so I could just live in that time when I didn't have to know coding, right? But here we are. Over the years, the DevOps and software defined networking, or SDN, in bold, so that's important, movement, among other factors, have significantly blurred the lines between network engineers, systems engineers, and developers. So, real quick, I know I'm like not going very quickly through this, but real quick, systems engineers, right? Systems engineering. I never knew what that was, and I'm not even sure I really encountered that like job title, that role, that phrase, like much, if at all, like until I got into aerospace, right? I work in aerospace now, and my understanding of a systems engineer is probably not the most robust understanding of it, right? Because I'm not one. But I encounter them in the context of like writing requirements for our stuff, like our vehicle, our equipment has to follow these specific guidelines that we've laid out, and they are really good at like writing those requirements, breaking down a system into smaller systems and so on and so forth, and then defining exactly how all of those systems need to function, behave, both separately and then together, I think. That's how I understand a systems engineer. And I'm curious if that is also the exact same like definition here. Sorry, I haven't looked at chat in a minute. Is he a punctuation abuser? Interesting. Okay, so the bot that I want to write would need the fundamentals of Python, but this book probably won't cover like everything for writing a bot. Fine, that's fine. We can request that Eric do that in his next book, right? I'm a gay man who grew up in South Texas in the 80s. All punctuation can be used as sarcasm. Amazing. Man, okay, now all y'all are just talking about old shit. I guess that's fine. I did say I wanted to be born back then and know how to use everything. The post 2001 America vibe is dramatically different. Yeah, for sure. Oh, Booger Bomb, going after your CCNA. I am so proud of you. It doesn't matter if you didn't do it back then. You're working on it now, and that's awesome. That's really awesome, actually. Best of luck. If anybody in the community can help you, please reach out. We're typically a pretty friendly bunch. There's only a few things that really push my buttons, and I think you'll be probably fine. So, I said I was going to get my CCNP like 2 years ago, and I didn't, right? Like I took Encore, I passed it, and then I took an RC and I failed it. And I felt really shit about that for a while, but now I don't really, because I still learned a lot studying for those tests, and I did pass one of them. Like I'm proud of that. Um, I used to call myself lazy about it, right? Like I didn't follow through, so I'm lazy. But actually, what happened is like I had a lot of life changes, good things, but very busy life changes happening at the time, and I just didn't have the time to get back on the wagon. So I I just didn't follow up with it, and I'm okay with that because I'm happy with where I am at the moment. Anyway, it's all good. If you get to it, you get to it, right? Everybody's journey is different. Anyway, all right. Let's get more than 2 paragraphs into this book. I'm sorry. The fact that you pick oh, excuse me. The fact that you have picked up this book suggests that you might already be an adopter of network DevOps. No, I'm not. Sorry, I'm not. Not yet. Or maybe you're considering going down that path of checking out network programmability. Maybe you've been working as a network engineer for many years, just as I had, and wanted to know what the buzz around the Python programming language is all about. You might even already have been fluent in the Python programming language, but wonder what its applications are in the network engineering field. Okay. So I'm being stupid, but these are all situations where this book is good for you, right? Like you could be fluent in Python, but not really know where it applies necessarily to networking. And this book is still a good resource for you, is basically the point here. Okay. I love this Venn diagram so much. I love it. Because he's just saying if you fall into any of these camps or are simply curious about Python in the network engineering field, I believe this book is for you. So he has this wonderful, simple Venn diagram. Python, NetEng, this book. We can make a meme out of this, I think. There's several memes. The shaking hand meme is immediately what I'm thinking about right now. Got a caption for it and everything. This is awesome. All right. Science diagrams that look like shit posts. Okay, this doesn't look like a shit post at all, but I love it. You know how like you can write and write and write and you can verbally say things and describe things as much as you want, but there's always going to be people out there who need a visual, right? I love that this is here for that reason, right? It's simple, but like also there are those of us, myself included, where it's like a visual is much easier to like I can read, but then I have to process and it takes a while, but having a visual is a very good way to learn. So even for simple concepts like, hey, this is who can fit in with this book, I still like the visual. All right, so there are already many great books written that dive into the topics of network engineering and Python separately. I do not intend to repeat their efforts with this book. Instead, this book assumes that you have some hands on experience in managing networks, as well as a basic understanding of network protocols. Okay, we're good there. It's helpful if you're already familiar with Python as a programming language. I am, sort of, but you don't need to be an expert. We will cover some Python basics later in the chapter as a baseline of Python knowledge. Again, you don't need to be an expert in Python or network engineering to read this book. Good, because I am neither of those things, for sure. This book intends to build on the basic foundations of network engineering and Python to help readers learn and practice various applications that can make their lives easier. Hello, welcome. Thank you for joining. Sorry if I'm a little late. I'm trying to keep my eyes on like both, chat and text. Thank you so much to everybody who's joining now. David Baum will give away Python for Network Engineering Udemy course for free today. Yay! It's Python Day is what it sounds like. It's Python. It's what am I saying? It's network automation with Python Day. That's it. That's awesome. Bumble's great. All right, where did I end? Yeah, okay. So this book intends to build on the basic foundations of network engineering and Python to help readers learn and practice various applications that can make their lives easier. In this chapter, we'll do a general review of some networking and Python concepts. The rest of the chapter should set the level of expectation of the prior knowledge required to get the most out of this book. If you want to brush up on the contents of this chapter, there are lots of free or low cost resources to bring you up to speed. Yeah, I highly recommend, at least for network engineering, and probably honestly, there's probably a lot out there for Python too. Just YouTube, just free ass YouTube videos. I've had a lot of people ask me, sorry, quick tangent. I've had a lot of people ask me for like resources, especially for like the CCNA. And I always, the number one thing I tell them is you can get a lot of knowledge for free on YouTube because there are so many saints out there who have just uploaded like lots of different content based on topics in the current CCNA. And yeah, it's awesome. That's how I learned subnetting. I didn't have to pay shit to learn subnetting. Thank you to all of you wonderful people on YouTube posting your knowledge for free. So anyway, yeah, Eric recommends the free Khan Academy and the official Python tutorials from the Python Software Foundation at python.org as well. So you can, if you can see those, I think at the end of the stream when I upload to YouTube and everything, I'll probably add like every relevant link that we get to in here. I'll put that in the description just so you have everything aggregated if that would be helpful. Yeah. YouTube and Google are definitely your friends for finding free tutorials and content. I have like a sort of underdeveloped, but getting there, list of CCNA resources on my website, trackandpacer.com. It's all other people's stuff, right? Like, and if I'm being honest, probably other people have a better aggregate of those materials, but I have some if you're interested and you want to go to trackandpacer.com and, you know, subject your eyes to the insane color scheme that I've got going on there right now. Okay, this chapter will pay a very quick visit to the relevant networking topics at a high level without going too much into the details. There's simply not enough space in one chapter to do a deep dive on any of the topics. To be honest, most of us don't get to a deep level when doing day to day jobs. It's true. It's true. What is the level of required networking knowledge? Well, judging from my experience of working in the field, a typical network engineer or developer might not remember the exact TCP state machine to accomplish their daily tasks. I know I don't. Me too. But they would be familiar with the basics of the OSI model and the TCP and UDP operations, different IP header fields, and other fundamental concepts. That is what we will cover in this chapter. Cool, because you know what? You know what? I never remember. I never remember like headers, IP header fields. I don't. I think that's one thing. I didn't struggle with subnetting in CCNA, but I struggled so badly remembering all the that shit. Uh, I zoned the fuck out. I have actually not found I have not found any way of learning like header fields for different like protocols and shit that like will stick in my brain. I don't know what that is. I just use a subnet calculator online even if I have a ZCMP. Yeah, that's fair. Like I will say this, it's not totally like calculus in everyday life if you're not like a mathematician or an engineer or whatever. It's not like that in that you never ever use subnetting again. I actually have in my limited experience been in a number of situations where I think, oh fuck, it would be really great. Let's see, I'm gonna in my head subnet this real quick. But not always, right? It depends. Um So yeah, subnet calculator, cool. It's just good for you to know what's behind that, right? Like to at least learn it once so that you have some understanding of like what is behind subnetting and why it is the way it is, right? I don't know. That's how I feel about a lot of things. Yeah. Headers have only ever come into play when dealing with PCAPs, firewall rules, and DDoS related filtering. That makes a lot of sense. Yeah. I'm working on IPv7, which will have built in support for self driving cars and microtransactions and be based on the blockchain. Thanks, Elon Leap Musk. I love Wireshark. I love Wireshark so much. I wish I could marry a Wireshark. Wireshark is just the best tool that I've ever. It is the tool by far that I use the most often, the most in depth. That is absolutely necessary, I would say, especially for my job today. It is absolutely necessary for me at work. I couldn't get a lot of shit done without Wireshark. I'll say that. Mhm. All right, we'll also look at a high level overview of the Python language first, just enough for those readers who don't code in Python daily to have ground to walk on for the rest of the book. Specifically, we'll cover the following topics: an overview of the internet. Yes, I love those kinds of things. I hope it's I hope it's got some history. I can already tell from the bottom of the page that it's going to be a good paragraph. I can see a little bit of it. The OSI and client server model, TCP, UDP, and IP protocol suites, Python syntax, types, operators, and loops, and extending Python with functions, classes, and packages. Cool. Of course, the information presented in this chapter is not exhaustive. Please check out the references for further information if required. As network engineers, often we're challenged by the scale and complexity of the networks we need to manage. They range from small home based networks, medium sized networks that make a small business go, to large multinational enterprise networks spanning across the globe. The most extensive network of them all is, of course, the internet, the interwebs. Without the internet, there would be no email, websites, API, streaming media, or cloud computing as we know it. Therefore, before we dive deeper into the specifics of protocols in Python, let us begin with an overview of the internet. I feel like that sentence could have ended with, like, let us begin with a solemn prayer to our God, the internet. That's what I feel like sometimes, because the internet is awe-inspiring for sure. All right, an overview of the internet. Let's see. Oh, hello. Random user asked, is that from the book Mastering Python Networking? Yes, it is. It sure is. That is exactly what I'm reading out of right now. And it sounds like maybe either you're joking or you've read this book, which is awesome because I'd love to have you read this. I'm on the 4th edition. Maybe you read a previous edition. I'm curious, but please join us. Yeah, Elon Musk definitely created Python. Of course. We all know that. Python pet working. That'd be a good username. Okay, so let's see. What is the internet? This seemingly easy question might receive different answers depending on each of our backgrounds. It's a series of tubes. The internet means different things to different people: the young, the old, students, teachers, business people, and poets could all give different answers to the same question. I want to know what a poet would say about what the internet is. $10 says tubes are in there somewhere. To a network engineer, the internet is a global computer network consisting of a web of internetworks, the internet, connecting large and small networks together. In other words, it's a network of networks without a centralized owner. Take your home network as an example. It might consist of a device that integrates the functions of routing, Ethernet switching, and wireless access points connecting your smartphones, tablets, computers, and internet-enabled TVs, blah, blah. Internet-enabled TVs together for the devices to communicate with each other. This is your local area network, or LAN. When your home network needs to communicate with the outside world, it passes information from your LAN to a larger network, often appropriately named the Internet Service Provider, or ISP. Excuse me. I had Chipotle for lunch. I think I saw someone say they did too, so homies. The ISP is typically thought of as a business that you pay to get online. They can do this by aggregating small networks into bigger networks that they maintain. The internet was invented by Al Gore. You have a you have a point. Foreign crypto, blockchain, and Twitter. That's the internet. Thanks, Elon Musk. Oh, you get your tongue twisted with track it pacer. Well, yeah, the other day, I've said my own username so many times, I've read it so many times. It feels weird to actually say packet tracer now. It feels very weird to me. It feels like I'm saying it wrong. The downside of you know, swapping syllables and making that your username. Your ISP network often consists of many edge nodes that aggregate the traffic to their core network. The core network's function is to interconnect these edge networks via a high speed network. At some of the more specialized edge nodes called Internet Exchange Points, your ISP is connected to other ISPs to pass your traffic appropriately to your destination. The return path from your destination to your home computer, tablet, or smartphone may or may not follow the same path through all these in between networks back to your original device, while the source and destination remain the same. This asymmetrical behavior is designed to be fault tolerant so that no one node can take down the whole connection. Let's look at the components making up this web of networks. I want to challenge somebody out there to write like a comprehensive, like, what is the internet from a network engineer's point of view without using the word net or network, other than like as part of the word internet, right? Or network engineer, you can say that. That would be really, really difficult, is what I'm saying. Okay, servers, hosts, and network components. Yeah. Hosts are end nodes on the network that communicate with other nodes. In today's world, a host can be a traditional computer. Thank y'all for the follows. I'm not sure if you're actually in here, but thank you so much if you are. Love it. Appreciate it so much. Hosts are end nodes on the network that communicate with other nodes. In today's world, a host can be a traditional computer, or it can be your smartphone, tablet, or TV. With the rise of the Internet of Things, or IoT, the broad definition of a host can be expanded to include an IP, feels weird to say internet protocol, to include an internet protocol or IP camera, TV set top boxes, and the ever increasing types of sensors we use in agriculture, farming, automobiles, and more. With the explosion of the number of hosts connected to the internet, they all need to be addressed, routed, and managed. The demand for proper networking has never been greater. Most of the time, when we're on the internet, we make requests for services. This could be viewing a web page, sending or receiving emails, transferring files, and other online activities. These services are provided by servers. As the name implies, blah, as the name implies, servers provide services to multiple nodes and generally have higher levels of hardware specification. In a way, servers are particular supernodes on the network that offer additional capabilities to their peers. We will look at servers again later in the client server model section. If you think of servers and hosts as cities and towns, the network components are the roads and highways that connect them together. This is a great analogy that almost always like works pretty well with people who aren't like super in tech or anything. The highways, roads type thing. Sometimes you bring like the postal service into it and like addressing and IP. Yeah, it's pretty good. In fact, the term information superhighway comes to mind. I'm sorry. I love y'all's usernames. I'm sorry. I just saw that Sweaty Butcher followed me and I just got so distracted. Uh so stupid. I love it. Okay. If you think of servers and hosts as cities and towns, the network components are the roads and highways that connect them together. In fact, the term information superhighway comes to mind when describing the network components that transmit the ever increasing bits and bytes across the globe. In the 7-layer OSI model that we will look at in the OSI model, these network components are layer 1 to layer 3 devices and sometimes venture into layer 4 as well. There are layer 2 and layer 3 routers and switches that direct traffic, as well as layer 1 transports, such as fiber optic cables, coaxial cables, twisted copper pairs, and some dense wavelength division multiplexing DWDM equipment. I love the bolding of that one because a lot of people don't know what the fuck that is, even if you're network engineers. Um, Collectively, host servers, storage, and network components make up the internet as we know it today. That was a really great explanation. Like that was a really great overview. That's the best one I think I've read yet, quite honestly. I've read a few books now about will that include like a history of the internet or like what is the internet type of thing. That was a very solid explanation. And I feel like somebody who's not very familiar with tech could understand that, right? Pretty well. The rise of data centers. In the last section, we looked at the different roles that servers, hosts, and network components play in the inter-network. Because of the higher hardware capacity that servers demand, they're often put together in a central location to be managed more efficiently. See, that's also a great explanation. I'm not even sure that I've ever read like an explanation of why we have data centers. Like it's always just like there's just data centers and that's where stuff is. And eventually we all learn from context clues or whatever, right? But like no one I don't think I ever had anyone actually say to me like this is why we have data centers. This is what they do. Maybe y'all have. I don't know. I'm curious because I don't think I've ever had an explicit explanation of why we have data centers. I find that fascinating. But that's a great explanation right there. Sounds like an EDM band. Yeah, you called me out. I was trying to stop laughing at Sweaty Butcher for a while. Sweaty Butcher, if you're here and you're watching, please chat. Oh man. Oh, quantum networking. Okay, I'm not gonna get into that. I'll let y'all talk about that in chat. Interesting. Yeah, why data centers? Okay, so because of the higher, I already read this, but because of the higher hardware capacity that servers demand, they're often put together in a central location to be managed more efficiently. Just really love that. We often refer to these locations as data centers. They can generally be classified into 3 broad categories: enterprise data centers, cloud data centers, and edge data centers. See, even this is something I've never had explicitly told to me. It's just something that you learn from context clue. I love it. Okay, thank you, Eric. Let's take a look at enterprise data centers first. Okay. In a typical enterprise, the company generally has business needs for internal tools like email, document storage, sales tracking, ordering, HR tools, and a knowledge sharing intranet. These services become file and mail servers, database servers, and web servers. Unlike user computers, these are generally high end computers that require higher power, cooling, and high bandwidth network connections. A byproduct of the hardware is also the amount of noise it makes, which is not suitable for a normal workspace. Mhm. The servers are generally placed in a central location called the main distribution frame, or MDF, in the enterprise building to provide the necessary power feed, power redundancy, cooling, and network connectivity. To connect to the MDF, the user's traffic is generally aggregated at locations closer to the user, which are sometimes called the intermediate distribution frame, or IDF, before they're bundled up and connected to the MDF. It's not unusual for the IDF MDF spread to follow the physical layout of the enterprise building or campus. For example, each building floor can consist of an IDF that aggregates to the centralized MDF on another floor in the same building. If the enterprise consists of several buildings, further aggregation can be done by combining the building's traffic before connecting them to the enterprise data center. Many enterprise data centers, sometimes referred to as campic, campus networks, follow the three-layer network design. Yeah, this is stuff you learn in CCNA typically, right? The layers are the access layer, the distribution layer, and the core layer. Of course, as with any design, there are no hard rules or one size fits all model. The three-layer designs are just a general guide. As an example, to overlay the three-layer design to our user IDF MDF example earlier, the access layer is analogous to the ports each user connects to. The IDF can be thought of as the distribution layer, while the core layer consists of the connection to the MDF and the enterprise data centers. This is, of course, a generalization of enterprise networks, as some of them will not follow the same model. All right, so here's the stuff that I want to learn about because that enterprise stuff and a little bit, I think the IDF, MDF stuff, I also might have learned in CCNA. Um, I'm really glad it's in this book. Like that was a good. It's good that he's going over this for sure. But I am not the most familiar with like data centers, cloud data centers rather. So I actually, I haven't heard the terms IDF and MDF for such a long time. I don't even remember where I first heard that. It was probably CCNA, and then I never touched it again because I don't remember, like, even in my first networking job, ever using the words IDF, MDF. I'm not anything not the MDF is really just aggregation. Okay. Hmm, interesting. Okay. So, with the rise of cloud computing and software or infrastructure as a service, IaaS, the data centers the cloud providers have built are big in scale, sometimes referred to as hyperscale data centers. What we refer to as cloud computing is the on demand availability of computing resources offered by the likes of Amazon AWS, Microsoft Azure, and Google Cloud without the user having to manage these resources directly. Many web scale service providers, such as Facebook, can also be grouped into this category. Because of the number of servers they need to house, cloud data centers generally demand a much, much higher capacity of power, cooling, and network capacity than any enterprise data center. That makes sense. Even after working on cloud providers' data centers for many years, every time I visit a cloud provider's data center, I'm still amazed at their scale. Yeah, I would love to visit one. I've never been. Excuse me. I've been to like an ISP ish data center. Never been to a cloud provider's data center. It must be amazing. Interesting. Your last job when building out networks for co-working and flex office spaces. Okay. So it must be just like enterprise world. I haven't really I've worked adjacent to the enterprise world, but never actually in it. So that might be why I haven't heard IDF, MDF much, if at all. Let's see. Where did I stop here? Just to give examples of their sheer scale, cloud data centers are so big and power hungry that they're typically built close to power plants where they can get the cheapest power rate without losing too much efficiency during the transportation of that power. Their cooling needs are so high. Yeah, I bet. Their cooling needs are so high that some are forced to be creative about where the data center is built. Facebook, for example, has built its Luleå data center in northern Sweden, just 70 miles south of the Arctic Circle, in part to leverage the cold temperature for cooling. Any search engine can give you some astounding numbers when it comes to the science of building and managing cloud data centers for the likes of Amazon, Microsoft, Google, and Facebook. That that makes sense. The Microsoft data center in West Des Moines, Iowa, for example, consisted of 1.2 million square feet of the facility on 200 acres of land and required the city to spend an estimated $65 million in public infrastructure upgrades. I didn't realize there was a Microsoft data center there. At the cloud provider scale, the services they need to provide are generally not cost effective or feasible to be housed in a single server. The services are spread between a fleet of servers, sometimes across many racks, to provide redundancy and flexibility for service owners. The latency and redundancy requirements, as well as the physical spread of servers, put a tremendous amount of pressure on the network. The interconnections required to connect the server fleets equate to an explosive growth of network equipment like cables, switches, and routers. These requirements translate into the amount of equipment that needs to be racked, provisioned, and managed. A typical network design would be a multi staged close network. Claw network. Someone please tell me how to pronounce that. I don't know. CLOS with a capital C. There's a reason it's capitalized. Is it like someone's name? I forget. Chloe? Chloe? Klaus. Close. Oh no. Klaus? Uh-oh. Klaus, like from the Umbrella Academy. Yeah, he's pronounced Klaus, right? Klaus. Okay, the guy who invented it. That's his name. Huh. Yeah. See, a lot of us, I think, have never said it out loud, and that's my problem as well. I think we even talked about this briefly on recording of the podcast, but it's been so long I've forgotten already. So whatever. Well, I'll call it Clo. I'll call it Clo. That seems to be that seems to be the sort of consensus, at least. Okay. Okay. So someone has a coworker that will berate you if you say it wrong. All right, we're going with Clo. Cool. All right, so here is a CLO network. Hang on, what did you say about it? A typical network design would be a multi-stage CLO network. So, all right, so this is management of the explosive growth of network equipment. So, in a way, cloud data centers and the increasing adaptations in other networks are where network automation becomes a necessity for the speed, flexibility, and reliability automation can provide. If we follow the traditional way of managing network devices via a terminal and CLI, the number of engineering hours required will not allow the service to be available in a reasonable amount of time. Hey, Ishmael, thank you for following. Not to mention that human repetition is error prone, inefficient, and a terrible waste of engineering talent. Thanks for following, random user. To add further complexity, there is often the need to quickly change some of the network configurations to accommodate rapidly changing business needs, such as redesigning a 3-tier campus network into a CLO-based topology. It's going to take me a minute to get used to that. Because for some reason my brain was like Klaus or Claus, Santa Claus. So, all right, so this is a CLO network. I'm not sure I can highlight. Okay, this is a CLO network. Need to read up a little bit more. This actually looks very familiar to me, and I think this looks like a at scale. This looks like a network I've definitely worked on before in a previous job. This looks like service provider land to me. Which I suppose makes sense because if it's supposed to be, I mean, it's not at the level of like AWS or Google or whatever, but If it's supposed to work for like hyperscale stuff, that makes sense, right? That an ISP would, I guess, implement things like that. I didn't know that was what I was looking at back in the day, actually. I remember thinking like, why are we doing it this way with some of it and this way with some other parts of it? Like it didn't I wasn't able to see the big picture as a new network engineer. And I'm not sure I'm sure somebody did try actually to like explain it, but I didn't take it all in or something back then. Read it today. How do you read Azure? Is it Azure or Azure? Azure? I feel like I've heard people pronounce it Azure, but I've I've heard like way more often. The majority of times that I've heard someone pronounce it, it's been Azure. I don't know. Flow is cool. All links are used at the same time, hugely scalable. Cool, cool. Uh-huh. Neither. I use Azure. Well, how do you pronounce the color? So when I was a kid, like a kid, and like learning all my words from just reading them and never hearing them, like I always in my head wanted to pronounce it Azure, but I don't think that's a pronunciation anywhere. But every once in a while in my brain, I want to say it like that, and I have to stop myself. So I don't even know how you pronounce the color. I don't even remember. I thought it was the same Azure. I don't know. Azure? Yeah, Azure. Okay. Interesting. Anyway, all right. So, in a way, cloud data centers and the increasing adaptations in other networks are where network automation becomes a necessity for the speed, flexibility, and reliability. I know I'm rereading something. Sorry, it didn't go into my brain. And reliability that automation can provide. If we follow the traditional way of managing network devices via terminal or CLI, the number of engineering hours required will not allow the service to be available in a reasonable amount of time. Not to mention that human repetition is error prone, inefficient, and a terrible waste of engineering talent. I appreciate that. It's true. To add further complexity, there is often the need to quickly change some of the network configurations to accommodate rapidly changing business needs, like redesigning a three-tier campus network into a flow-based topology. Okay. Personally, cloud data center networking is where I started my path of network automation with Python several years ago, and I've never looked back since. Okay. I mean, it makes sense. You got a ton of shit to deal with. Like, that's not going to be efficient for people to manually deal with every time. All right. Thanks. Hold e-clocks? Hold e-clocks? I need to make those last for longer so I can figure out how to pronounce your username. Thanks for following. All right, so let's talk about Edge Data Center. Everybody okay? We cozy? We still got our blankies and our cookies and our need to go make some more tea maybe? It's probably run out by now. How we doing, UK? It's 3 what is it, 3:20 AM now for you? Meshy man. Yeah, go get your tea, come back, get cozy. Mocha ice cream. Hell yeah. 3:20 AM. All right, I got it. Man, if you're actually on and that is your local time, thank you so much for being here. And I won't blame you at all if you just like fall asleep to the sound of me talking about edge data centers. Finished all the cookies. Go get some cake. Make some tea. You deserve the snacks. It's the weekend, right? Nap and leave this playing. Yeah, that's totally fine. When I used to stream more consistently, I would just constantly be like, just go to sleep. Like, if you learn something, you learn something. You'll learn in your dreams as I talk. All right, edge data centers, let's go. If we have sufficient computing power at the data center level, why keep anything else but at these data centers? All the connections from clients worldwide can be routed back to the data center servers, and we can call it a day, right? Mm, The answer, of course, depends on the use case. The most significant limitation in routing the request and session all the way back from the client to a large data center is the latency introduced in the transport. In other words, significant latency is where the network becomes a bottleneck. All right, so while I've still got, I'm going to keep going, but while I've still got a good number of people here, and I was reminded that it's like after 3 a.m. in Europe. I just want to say this now so I don't like I'll say it again later and I'll keep repeating, but fuck, hang on. Find the So, okay, so there Eric Cho, the author of this book in conjunction with the podcast where I'm a co-host, The Art of Network Engineering, are actually doing a giveaway of a few copies of this book. And so, in order to determine the people who win those copies, I forget exactly how many copies, I'm sorry. 2, maybe 3, I think. Eric, correct me on that if I'm wrong. He may not be on yet. Anyway, they're giving away a few copies of this book, more than one. And the way that, we're going to figure out who wins to enter, I'm going to post a link in the chat. I posted this earlier if you were here earlier, but I didn't explain. So the way we're going to have people enter is click on that link, sign up for the community. So this is Eric's own created like community around the mastering Python networking book. And it's basically a nice little place where people who are learning to do all of this stuff can go and like share knowledge, right? And learn together. It's also a place where if you have feedback on the book for Eric, you can tell him there. So all you need to do, it's free and everything. All you need to do is just sign up. I think you give it an email address and some basic info. Then you're going to be emailed an invite email. Click on the link and then that completes your sign in process. And then once you add, I think you need to add like your first name or something like that to like a form, and then you submit it and the world will be your oyster. You'll be open to the community. It's a nice little interface. I'm there. I haven't posted anything yet because I don't know shit yet. I haven't started my automation journey. This is literally the start of it right here on the stream. But anyway, go there and comment on. Hang on, I'm trying to grab it real quick. Well, okay, if I try to share this now, it's just going to be super clunky. But anyway, Eric has posted, once you sign in, after you've clicked on the invite link and you've added just like your first name, once you move on, you'll see like the home dashboard of that website. And if you scroll down a little bit, we've got posts for Eric has been posting. So he's posted about this live stream. So leave a comment, say something in there. Just let him know that you see it. And that's how we're going to determine the winners of the book. So take a look. It'll be like a random draw, right? Like if you comment, your username, or rather your email probably, will be just put into like a spreadsheet, and with a random number generator, we're going to pick you. That's basically how we're going to pick the winners. So hopefully as fair as possible. This is just like a new community platform and really want to highlight it for Eric because I think it's going to be a good place for people to learn and share knowledge. So I'm excited. Anyway, thank you for listening. I will go back over that later on in the stream as well for anybody who might miss it. Before I lose the people in Europe for whom it is past 3 a.m. Wanted to let you know. I will also tweet about it as well later on. I'm sure Eric will, and the Art of Network Engineering Twitter at Art of NetEng will also tweet about this giveaway as well. So there will be multiple, opportunities to sign up. I don't have like a target date or like an end date for it yet. I think that's kind of flexible. So anyway, this is just the announcement at the beginning of that. So, all right. Anyway, yeah. All right. Significant latency is where the network becomes a bottleneck for sure. Of course, any elementary physics textbook can tell you that the network latency number would never be zero. Even as fast as light can travel in a vacuum, it still takes time for physical transportation. In the real world, latency would often be much higher than light in a vacuum. Why? Because the network packet must traverse through multiple networks, sometimes through an undersea cable, slow satellite links, 4G or 5G cellular links, or Wi Fi connections. How can we reduce network latency? Well, one solution would be to reduce the number of networks the end user requests traverse through. We can try to be as closely connected to the end user as possible, perhaps meeting the user at the edge where the requests enter our network. We can place enough resources at these edge locations to serve the requests. This is especially common for servicing media content such as music and videos. Awesome. BA578 just got confirmed. Oh, random user. Any chance the books will be signed? I don't know, but I will ask. I will ask. It's possible they're coming straight from the publisher. I am not sure. So I will double check. By the way, if you want to if you want to buy a copy of the book, you can just get it on Amazon right now, by the way. FYI. Trying to do a site-to-site VPN link to Australia. Quantum entanglement can reduce network latency by creating an entangled by physically separate quantum system. Oh, thanks, Othugmuffin? Is that how I pronounce your name? Yeah, thanks. I appreciate it. I hope to be streaming a little more consistently in the future, but thank you for joining for the limited amount of time you could. I appreciate it. Okay, speed of light in a single mode fiber is only about 2/3 the speed of light in a buffer will disappear. Okay, this is interesting. I can't read everything at the moment, but like got some interesting theories on latency in the chat. I like it. Okay. So let's take a minute and imagine that you're building the next generation of video streaming services. To increase customer satisfaction with smooth streaming, you would want to place the video server as close to the customer as possible, either inside or very near to the customer's ISP. Also, for redundancy and connection speed, the upstreaming of the video server farm would not just be connected to one or two ISPs, but all the ISPs that we can connect to reduce the hop count, thus reducing the number of devices we need to pass through. All the connections would have as much bandwidth as needed to decrease peak hour latency. This need gave rise to the peering exchanges, edge data centers of big ISP and content providers. Even when the number of network devices is not as high as cloud data centers, they too can benefit from network automation in terms of the increased reliability, flexibility, security, and visibility network automation brings. If we extend the concept of edge nodes and get creative, we can see that some of the latest technologies, such as self driving cars and shout out Elon Leap Musk, software defined wide area networks or SD-WANs, are also applications of edge nodes. The self driving car needs to make split second decisions based on its sensors. SD-WAN routers need to route packets locally without the need to consult a central brain. These are all concepts of intelligent edge nodes. I like that. I haven't really read explicitly about intelligent edge nodes, but it makes sense, right? As with many complex subjects, we can tackle the complexity by dividing the subject into smaller, digestible pieces. Networking breaks the complexity by using layers to model the functions of its elements. Aha, I see where we're going. Over the years, there have been different networking models. We will look at two of the most important models in this book, starting with the OSI model. Okay, being right next to the ISP doesn't mean you'll have the shortest path to it either. I can rant on that forever. I'd love to hear that rant. I really would. I something I really want to get better at, which is has me considering like the CCNA design track just for learning purposes is yeah, I just don't have a lot of I don't really have any design experience, right? And I'd love to like I need to train my brain to get into the mindset of someone who's designing networks and not just troubleshooting them. Um or like implementing somebody else's design, right? Like I want to get to that higher level. So there's a lot of shit out there. A lot of things to consider when you're designing a network. Okay. Yeah, something with the self-driving cars that always gets me is like how do you not how do we prevent that? What's the security on those? Is it truly hackable? You know? Like there's ethernet in a lot of cars happening. So, I don't know. I'm so curious about the computer systems in a car. And it depends on the car, right? So you got the self-driving ones, which are going to be different, right, than your other non-self-driving cars. And then you've got some cars that actually are not fully self-driving, but they do have some capabilities of self-driving, right? Like my car, like cruise control is an easy one, but like now they have a smarter cruise control where it doesn't just keep your car going at the same speed, but if you're going a certain speed and someone in front of you is going slower than that, it'll adjust to that. And you basically, the cruise control is set to a maximum or like an ideal speed, right? But it's smart enough to like sense when a car's in front of you and like not hit it, you know? Also, what is it called? Lane control, I guess, where you can like your car can sort of, that's when it starts to, if you have cruise control and lane control like both on, it starts to sort of feel like you've got a self-driving car. It's not, but it sort of starts to feel that way, right? Lane control in my experience, at least with the cars I've had, a little spotty. It's fine, but you still have to really pay attention, right? Lane assist, thank you. Yeah, everybody go trace route to quad eights and see what you get hop-wise to your nearest Google node. I'm curious. Okay, the OSI model, everybody's favorite. Every time I post any shit about this, like a TikTok or just like some kind of post, Twitter post, people lose their fucking bananas over the OSI model. They hate it. People hate the OSI model. And I find that interesting. I like that it's a way to like illustrate concepts. I think it does a fairly good job considering like all the shit out there now. Like it does a fairly good job at helping describe some things, but I understand some of the critiques of it too, where it's like, why do we need this session and presentation layers? Like really? None of that shit makes sense. And it's like really hazy. And then there's some stuff where it's like, is it layer 3? Is it layer 4? Is it layer 2? Is it layer 3? Somewhere in between. Like what the fuck is MPLS, right? You know, that kind of, it's an interesting conversation. But anyway. OSI is a great starting model to communally dunk on. All that a conversation starter. Yeah, yep. Oh, Mr. Hamill, you love the OSI model. Okay, see, I tend to like be more understanding about the OSI model, but maybe that's just my inherent like I need to defend it if people are automatically shitting on it no matter what it is. The OSI networking system would have relied on every router having knowledge of every other router on the entire network. Oh yeah, okay. So if this were an actual implemented model instead like TCP/IP instead of like just a call it like an illustrative model, right? Anyway, we're probably gonna as conceptual model. That's what I wanted to. Eric's already writing this better than I could ever say it. So let me actually read some of this. No network book is complete without first going over the OSI model. The model is a conceptual model that componentizes. I love that. It took me a second. Okay, the OSI model is a conceptual model that componentizes the telecommunication functions into different layers. Wow, I could not say that sentence at all. I did not do that. Okay. You get it though. I'm not going to go back over it. Okay. The model defines 7 layers, and each layer sits independently on top of another one with defined structures and characteristics. Okay, I think I need some water. I'm not speaking well. Oh, compartmentalize. That is a good synonym. I don't know. I mean componentize. Let's see. I can see an argument though for componentize, but I see what you're saying. Compartmentalize might be the synonym we're looking for there. Anyway, okay, we've got 7 independent layers, all of them sitting on top of the other one below it, right? For example, in the network layer, IP is located on top of the different data link layers, such as Ethernet or frame relay. The OSI reference model is a good way to normalize different and diverse technologies into a set of common languages that people can agree on. This greatly reduces the scope for parties working on individual layers and allows them to look at specific tasks in depth without worrying too much about compatibility. Man, though, let me just quickly say trying to explain, so it's one thing to like explain this concept to people who are not very familiar with tech and are just sort of like new to everything. But when you try to explain like the difference between layer 2 and layer 3, like the difference between a MAC address and IP address to like a software developer who like didn't learn the OSI model and like has this concept of networking already sort of baked in their brains, but it's not totally accurate. That shit is hard. Like it's so difficult to go over like simple stuff in the OSI model with professionals who are already in tech and think that they know like everything well and they don't. Or like maybe they sort of have a picture but it's not complete. It's very, very difficult in my experience. And kind of funny. Blockchain is the 8th layer of the OSI model. They're trying to make it that. Okay, it was difficult for me to understand the concept of the OSI model when I first heard and learned of it in 2015. Well, yeah, and it's not a perfect model, right? I'm not saying it's like super easy to understand. Um, it's it's not implemented like TCP/IP. It's abstract. So ultimately, I'm curious how you were first introduced to the concept of the OSI model because there are good explanations and there are not so good explanations out there, and I've seen a number of both. Okay. I like that. A MAC address is a street address. An IP address is a phone number. I like that a lot. That actually brings in encapsulation, doesn't it? That is really good. It's kind of sneaky how good that is, actually. Nice. Okay, high school CCNA class back in 2003. Yeah, I'll say this. I'm not calling high schoolers stupid, but if I were a teenager learning this, I would find it fascinating. I'm not sure how much it would stick with me, though. I don't know. It's tough to know. But anyway, yeah, sometimes you have to go over it a bunch and then you forget it. The only reason I feel like I know the OSI model very well is because I had to rote memorize that shit so hard and like all these different protocols that fell under each different layer. Like I had to memorize all that shit to pass the CCNA. Woof. And I'm pretty sure so I took it in two parts. I took the ICND 1 and 2. And I'm pretty sure in both of those exams there were questions about the OSI model and like protocols in it. So you had to like know that shit really well. And I feel like that's one of the things that's really stuck with me like the best since CCNA. Anyway. Damn, I'm so jealous of you people who went to high school and had an actual CCNA lab or like an actual lab of some kind and you like had those classes. I'm so jealous. I'd like to say that I would have taken those classes back in the day, but I was also an idiot as a teenager, so who knows? But I think it's great that they're in high schools. I think it's wonderful. Honestly, I think they should be in middle schools too, as like a little introductory. I mean, I think that would be so cool. I don't know. Yeah, okay. Yeah, Hamel, you've got the right idea, right? Like grouping it into, layer one, physical and link management. It does make sense to put those two together, even though we still end up with, I think, the TCP IP model. I think it still separates them, right? With layer two. Well, okay, link management. Never mind. I'm sorry. I was thinking data link layer when you said link management. But yeah, layer two switching, right? MAC addresses, layer three routing, layer four protocols, and then 5 through 7 is just application. Yeah, is a good way to think of it. Because honestly, 5 through 7, it's like as a network engineer, you don't, unless you're jack of all trades, wearing many hats at a small enterprise or something, you may not really be interacting with 5 through 7 like at all, ever. I don't know. Now y'all are making me wonder if my high school maybe got some kind of a lab. That'd be cool after I graduated. Anyway, anyone use Boson NetSim for designing, modeling a network? Oh, I forgot they have labs. I have never actually used Boson's labs. I was about to get really excited about like their practice exams. They were excellent for me in passing the CCNA, at least the practice exams. All right, so anyway, sorry, I got to get through this. I apologize. The OSI reference model is a good way to normalize different and diverse technologies into a set of common languages that people can agree on. This greatly reduces the scope for parties working on individual layers and allows them to look at specific tasks in depth without worrying too much about compatibility. So then we've got I like this. He's got explanations here of what each of the layers does. And the PDU. Interesting. We have host layers and media layers. I guess I'm not actually familiar with calling any of these host layers or media layers, but I feel like it does make sense how he's grouped them based on the context. Hmm. SD-WAN gonna have you looking at layer 7 too. That's a good point. That's a good point. We are moving away from the CLI and like more into this like more abstract GUI type of environment. And then you've got like automation handling a lot of things. Things are going to change. Things are slowly changing here and there with automation. I guess that's why we're reading this book, right? The OSI model was initially worked on in the late 70s and was later published jointly by the ISO, what is now known as the, oh my God, Telecommunications Standardization Sector of the International Telecommunication Union. Jesus Christ. ITUT. That's easier. It's widely accepted and commonly referred to when introducing a new topic in telecommunication. Around the same time as the OSI model development, the internet was taking shape. The reference model the original designer used for the internet is often referred to as the TCP/IP model. The TCP and the IP were the original protocol suites contained in the design. This is somewhat similar to the OSI model in the sense that they divide end to end data communications into abstraction layers. Okay. Yeah, we got diagrams now. Zoom out a bit. I hope that's still readable. Maybe if I. What's different in the TCP IP model is it combines layers 5 to 7 in the OSI model in the application layer, while the physical and data link layers are combined in the link layer. Okay, I was thinking they were separate. I have forgotten about TCP IP model a bit. Which is hilarious because I think I did a TikTok on it not too long ago. Whoops. Okay. Network topology, host A to router to host B, data flow. I think we're going to get this is the Internet Protocol Suite. Interesting. Yeah. Okay. So we get so down here below we've got our physical shit, Ethernet, our twisted pair cable, copper cable, fiber, whatever, fiber, satellite, etc. And then we've got the link layer above that. Then we've got the internet layer. Then we've got the transport layer. Internet and transport both map to 3 and 4 in the OSI and TCP model. And then you've got application layer, which is wonderful actually that you've combined 5 through 7 because it does seem a little bit useless now to not combine 5 through 7 at this point in time. Both the OSI and TCP IP models are useful for providing standards for end to end data communication. We will refer to either the OSI or the TCP IP model when needed, such as when we're discussing the web framework in the upcoming chapters. Just like models at the transport layer, there are also reference models that govern communication at the application level. In the modern network, the client server model is what most applications are based on. We'll look at the client server model in the next section. And here it is, the next section. The client server model. The client server reference model demonstrated a standard way for data to communicate between two nodes. Of course, by now we all know that not all nodes are created equal, even in the earliest advanced research projects, agency, network, or ARPANET days. There were workstation nodes and there were server nodes, and with the purpose of providing content. Sorry, I can't talk. Even in the earliest ARPANET days, there were workstation nodes and there were server nodes with the purpose of providing content to other workstation nodes. These server nodes typically have higher hardware specifications and are managed more closely by engineers. Since these nodes provide resources and services to others, they're appropriately referred to as servers. Servers typically sit idle, waiting for clients to initiate requests for their resources. This model of distributed resources that are requested by the client request is referred to as the client server model. Why is this important? If you think about it for a minute, the importance of networking is greatly highlighted by this client server model. Without the need to transfer services between clients and servers, there's not a lot of need for network interconnection. It's the need to transfer bits and bytes from the client to the server that shines a light on the importance of network engineering. Of course, we're all aware of how the biggest network of them all, the internet, has been transforming the lives of all of us and is continuing to do so. Mostly through memes and porn, am I right? Thanks for following. I'm sorry I missed your username just there, but thanks. You might be asking, how can each node determine the time, speed, source, and destination every time they need to talk to each other? Well, this brings us network protocol. I need a magic sound effect right there. I don't have a soundboard yet, so forgive me. But that's what I would have inserted if I could. Network protocol suites. Yay! In the early days of computer networking, protocols were proprietary and closely controlled by the company that designed the connection method. If you were using Novell's IPX SPX protocol in your hosts, the same host would not be able to communicate with Apple's AppleTalk hosts, and vice versa. These proprietary protocol suites generally have analogous layers to the OSI reference model and follow the client server communication method, but aren't compatible with each other. The proprietary protocols generally only work on LANs that are closed without the need to communicate with the outside world. When the traffic does need to move beyond the local LAN, typically a protocol translation device, like a router, is used to translate from one protocol to another. For example, to connect an AppleTalk based network to the internet, a router would be used to connect and translate the AppleTalk protocol to an IP based network. The additional translation is usually not perfect, but since most of the communication happened within the LAN in the early days, it was accepted by the network administrators. However, as the need for inter network communication rises beyond the LAN, the need for standardizing the network protocol suites becomes greater. The proprietary protocols eventually gave way to the standardized protocol suites of TCP, UDP, and IP, our favorite, which greatly enhanced the ability of one network to talk to another. The internet, the greatest network of them all, relies on these protocols to function properly. In the next few sections, we'll look at each of the protocol suites. We're really going into depth here. It feels like we're going in depth a bit, and I'm happy with that. I feel like this is a good refresher, the basics, before we actually get to Python. Although I am sorry it's taken me a while to get through it. I apologize. I know we came here for Python, and we're still in networking. My dog's getting upset. There's people outside. She wants to bark at them. Stop it. Hey, it's okay. I've closed her in here. I may have to let her out. I'm not going to let her out just so she can bark at people. All right. The Transmission Control Protocol, TCP. It's one of the main protocols used for the internet today. If you've opened a web page or have sent an email, you may have come across the TCP protocol. I'm sorry. Why did I say may? I inserted that in there. If you've opened a web page or sent an email, you have come across TCP. This protocol sits at layer 4 of the OSI model, and it's responsible for delivering the data segment between two nodes in a reliable and error-checked manner. TCP consists of a 160-bit header that contains, among other fields, source and destination ports, a sequence number, an acknowledgement number, control flags, and a checksum. Not needing to know legacy crap. Yeah, IPX and SPX phased out a long, long time ago. All right. And here we have a nice little diagram for a TCP header, mostly in frame. Base is blocking the last few bits, but ta-da! This is the kind of stuff that I could never memorize because it was just so boring to me, if I'm being honest. But this is helpful, right? We probably need to know this. Um, all right, functions and characteristics of TCP. TCP uses datagrams, sockets, or ports to establish host-to-host communication. The standard body, called IANA, designates well-known ports to indicate certain services, such as port 80 for HTTP and port 25 for SMTP. She's on the floor snoring. You need to chill out. You're okay. Really mad at me. Okay. The server and the client server model typically listens on one of these well known ports in order to receive communication requests from the client. The TCP connection is managed by the operating system with the socket representing the local endpoint for the connection. The protocol operation consists of a state machine, which the machine needs to keep track of when it's listening for an incoming connection during the communication session, as well as releasing resources once the connection is closed. Each TCP connection goes through a series of states, such as listen, SYN sent, SYN received, established, fin wait, closing, last act, time wait, and closed. The different states help in managing the TCP messages. I really like the phrase, the term state machine. I think it sounds really cool. Anyway, all 9600 baud of speed. Oh my god. How long ago was that when you were playing Doom over Serial? Yeah, well, you don't have to answer that, but I couldn't even name. Was this 90s? Yeah, okay. It was 90s. Yeah, now memorize all the fields, their min and max values, and what bit starts and ends at. Yeah, I could never fucking do that. I really couldn't. I could not do that today. Interesting. So at one point, Ethernet was really expensive and Serial was cheaper. I never realized that. I'm used to thinking of Ethernet, especially like the copper twisted pair cabling, as the cheapest option, right? But yeah, I'm sorry. Yes, I am not studying for a particular certification. Although I understand why it looks this way because we're going over networking concepts. We're at the very beginning of a book called, as Mr. Hamill just said, Mastering Python Networking. So eventually we're going to get into some Python. We're just not there yet because I keep talking and chatting. So I'm sorry. All right. TCP messages and data transfer. The biggest difference between TCP and UDP, which is its close cousin on the same layer, is that it transmits data in an ordered and reliable fashion. The fact that TCP operation guarantees delivery is often referred to TCP as a connection. Okay, so hang on. The fact that TCP operation guarantees delivery means that TCP is often referred to as a connection oriented protocol. It does this by first establishing a three-way handshake to synchronize the sequence number between the transmitter and the receiver. SYN, then SYN-ACK, and then ACK. That's our three-way handshake. The acknowledgement is used to keep track of subsequent segments in the conversation. Finally, at the end of the conversation, one side will send a FIN message and the other side will ACK the FIN message as well as sending a FIN message of its own. The FIN initiator will then ACK the FIN message that it received. So FIN, ACK FIN, ACK, I think, right? At the end of the conversation, we have a FIN. The other side says ACK FIN, and then side A again goes ACK. You know what I miss? Sorry, I'm gonna stop talking. I'm gonna stop chatting soon. But like, I miss at my first job as a network engineer. I find this so endearing. I didn't realize it till I left, and nobody else did this. But in our uh, what did we use? Slack. In our Slack like chats and stuff, my networking team would always say "ack," like acknowledgement. You know, if someone said, "Hey, go do this," they'd be like "ack," or like if someone was like, "Hey, I need help doing this." The next person that wanted to help would be like ack, and we know that person was on it, like acknowledge. I just thought it was really cute, and I missed that. So as many of us who have troubleshot a TCP connection can tell you, the operation can get quite complex. One can certainly appreciate that most of the time the operation just happens silently in the background. A whole book could be written about the TCP protocol. In fact, many excellent books have been written on the protocol. As this section is a quick overview, if interested, the TCP IP guide at tcpipguide.com is an excellent free resource that you can use to dig deeper into the subject. And it's a nice clickable URL. The user datagram protocol. All right, UDP. UDP is also a core member of the protocol suites used. Like TCP, it operates on layer 4 of the OSI model that's responsible for delivering data segments between the application and the IP layer. Unlike TCP, the header is only 64 bits, which only consists of a source and destination port, length, and checksum. The lightweight header makes it ideal for applications that prefer faster data delivery without setting up the session between the two hosts or needing reliable data delivery. Perhaps it's hard to imagine with today's fast internet connections, but the lightweight header made a big difference to the speed of transmission in the early days of X.21. Shit, I don't even know what that is. And frame relay links. Someone can tell me what that is. Besides the speed difference, not having to maintain various states, such as TCP, also saves computer resources on the two endpoint. So this is a much, much, much easier to digest like header field diagram, right? Because it's not as complex as TCP in the end. You might now wonder why UDP was ever used at all in the modern age. Given the lack of reliable transmissions, wouldn't we want all the connections to be reliable and error free? Yeah, but we also want fast data, right? If you think about multimedia streaming, video streaming, or Skype calls, those applications benefit from a lighter header when the application just wants to deliver the datagram as quickly as possible. You can also consider the fast DNS lookup process based on the UDP protocol. The trade off between accuracy and latency usually tips to the side of low latency. Yeah, low latency is very, very important. I think we all know that. Hello, friends. Our team always reacts with the eye looking emoji to acknowledge they're checking on something. Yeah, yeah, yeah. You know what? We did a little bit of that too. But it was a lot of it was just ack. But I love the side eye emoji. One of my favorite ones for anything. I could tell you a TCP joke, but I have to keep repeating it until you got it correctly. You know, normally I get the UDP version of that, so this is a nice, like, refreshing difference there. Oh, does Elon Musk hate IPv4? What's the best part about UDP jokes? If the other person doesn't get it, I don't care. Oh my god. This is just gonna be another, like, half hour of this. Okay. Alright, so we can learn okay, we straight up can just go to Wikipedia and learn a lot about UDP. That makes sense. Okay. The Internet Protocol. As network engineers will tell you, we live at the IP layer, which is layer 3 on the OSI model. IP has the job of addressing and routing between end nodes, among others. The addressing of an IP is probably its most important job. The address space is divided into two parts, the network and the host portion. The subnet mask is used to indicate which portion in the network address consists of the network and which portion consists of the host. We're getting into subnetting a little bit now. By matching the network portion with a 1 and the host portion with a 0. IPv4 addresses, IPv4 expresses the address in the dotted notation, for example, 192.168.0.1. The subnet mask can either be in a dotted notation like 255, 255, 255, 0, or use a forward slash to express the number of bits that should be considered a network bit. So slash 24 for triple 255s. Here's our nice little IPv4 header format. The IPv6 header, the next generation of the IP header of IPv4, has a fixed portion and various extension headers. It has so many different extensions. My ears are in pain. I'm going to have to like swap off like things now. Hopefully that doesn't look too weird. Okay. The IPv6 next header field in the fixed header section can indicate an extension header to be followed that carries additional information. It can also identify the upper layer protocols such as TCP and UDP. The extension headers can include routing and fragment information. For example, the extension header can include how the original packet is fragmented so the destination node can't reassemble the packet accordingly. As much as the protocol designer would like to move from IPv4 to IPv6, the internet today is still mainly addressed with IPv4, with some of the service provider networks addressed with IPv6 native. Here we go. That's a debate to have. All right, IP NAT and network security. NAT is typically used for translating a range of private IPv4 addresses into publicly routable IPv4 addresses. Sorry, my brain just zoned out for a second there. NAT is typically used for translating a range of private IPv4 addresses into publicly routable IPv4 addresses. But it can also mean a translation between IPv4 and IPv6, such as at a carrier edge when they use IPv6 inside of the network that needs to be translated to IPv4 when the packet leaves the network. Sometimes NAT6 to IPv6 is used as well for security reasons. Security is a continuous process that integrates all the aspects of networking, including automation and Python. This book aims to use Python to help you manage the network. Security will be addressed as part of the following chapters in the book, such as using Python to implement access lists, ACLs, search for breaches in the log, and so on. Cool. We'll also look at how we can use Python and other tools to gain visibility in the network, such as a graphic network topology dynamically based on the network device information. IP routing concepts. IP routing is about having the intermediate devices between the two endpoints transmit the packets between them based on the IP header. For all communication that happens on the internet, the packet will traverse through various intermediate devices. As mentioned, the intermediate devices consist of routers, switches, optical gears, and various other gears that might not examine beyond the network and transport layer. Dog's getting annoyed with me again. Are you okay? Hang in there. It's technically her birthday today, and I haven't given her her cake, so that could be another reason why she's annoyed with me. All right, in a road trip blah, blah, blah. In a road trip analogy, you might travel in the United States from the city of San Diego in California to the city of Seattle in Washington. The IP source address is analogous to San Diego, and the destination IP address can be thought of as Seattle. On your road trip, you'll stop by many different intermediate spots like LA, San Francisco, and Portland. And these can be thought of as the intermediary routers and switches between the source and destination. Solid. NAT isn't security. Okay, maybe for those of us learning the basics it is. I don't know. Elon Musk, you're really I'm impressed with you. You've been on for like 2 hours now and like you are committed to the bit, my friend. Thank you for the levity. Why was this important? In a way, this book is about managing and optimizing these intermediate devices. In the age of mega data centers that span the size of multiple American football fields, the need for efficient, agile, reliable, and cost effective ways to manage the network becomes a major point of competitive advantage for companies. In future chapters, we'll dive into how we can use Python programming to effectively manage a network. Now that we've looked at network reference models and protocol suites, we're ready to dive into Python. Woo! We made it. We made it, and we're not even overtime yet. I was planning to take this until 7:30 Pacific time, 7:30 my time. So basically make the stream 2 full hours long. So for those of you in the UK time zone, that'd be like 4:30 a.m. if you're still awake by now. Is everybody doing okay? How are we doing? You stuck with me all the way through the networking stuff. I'm so sorry. It's my fault. It took forever. No reason to use it on IPv6. Oh, yeah. Right. The whole point of NAT was because we're running out of IPv4 addresses. And no, it's not. What am I fucking? I mean, it is, but anyway, public to private shit. It's not really we're not running out of IPv6 addresses, so I'm curious if we ever will. It's technically possible, right? But yeah, it's all good. I think we all need a refresh on networking, right? I needed a refresh on networking. Yeah. No way. You have a full There's no way. So Google doesn't support DHCPv6 properly? I'm curious about that. Also, I do want to hear your thoughts because I don't have strong thoughts. I will get to Python, I promise. I'm really curious. I want to hear more about why we have such a disagreement or maybe a misunderstanding about NAT being for security. Like I know what NAT is for, right? Like it's public to private IP translation, right? But and that and like ACLs, I feel like we do at least at the beginning of our careers, maybe in CCNA. I don't know if it's like the current CCNA has this in there or not, but like I'm pretty sure in my CCNA studies, it ACLs were at least referred to as like technically like weak, but technically a security thing. And I think NAT as well. And so I'm curious why we have such a strong reaction to like NAT being named as a security thing. I'm truly curious because I don't have enough experience and knowledge to like really have an educated opinion on it. But you do see it named like that. Anyway, please, I'm curious about your thoughts, but let's get into Python. In a nutshell, this book is about making our network engineering lives easier with Python. But what is Python and why is it the language of choice of many DevOps engineers? In the words of the Python Foundation Executive Summary, which we can find on python.org, you can see there it is. You can see that URL. Okay, here's the quote from python.org. Python is an interpreted, object oriented, high level programming language with dynamic semantics. Its high level built in data structure combined with dynamic typing and dynamic binding makes it very attractive for rapid application development, as well as for use as a scripting or glue language to connect existing components together. Python's simple, easy to learn syntax emphasizes readability and therefore reduces the cost of program maintenance. Cool. If you are somewhat new to programming, the object oriented and dynamic semantics mentioned in the summary probably don't mean much to you, but I think we can all agree that, quote, rapid application development, thanks Mac NV for following. I think we can all agree that rapid application development and simple, easy to learn syntax sound good. Yes, I can say I agree with that. Python as an interpreted language means there is little to no compilation process required before execution. So the time needed to write, test, and edit Python programs is significantly reduced. For simple scripts, if your script fails, a print statement could be all you need to troubleshoot the issue. I mean, that's really nice. Honestly, Python being like the only real like language that I've learned or become familiar with, I'm way more familiar with Python than any other language, and I just always have kind of assumed that a lot of them work like Python do, but of course they don't because they're different languages. Anyway, I'm worried about my capacity to learn any other languages than Python is what I'm saying. Ah, yes, Python, the batteries included language. That's good, right? NAT comes into play on firewalls, so firewalls equal security, therefore NAT equals security. I see why that association is made. That sheds some light on it. Okay. Hey, you've only got like 4 minutes to deal with this. Get you out. She's being an idiot. Yeah, okay. Python is, in my honest opinion, easier than most other language, but has pitfalls. That's generally like what I've heard about Python. Okay, using the interpreter also means that Python is easily ported to different operating systems like Windows and Linux. A Python program written on one operating system can be used on another with little to no change. The functions, modules, and packages encourage code reuse by breaking a large program into simple reusable pieces. Okay. The object oriented nature of Python, I don't totally understand what object oriented means, but like, I, yeah, I can imagine. Hang on, I'm going to do something. The chat text is just so small. I want to actually like see y'all's comments on the screen. So I'm going to edit that. There we go. Hang on. There we go. Okay, good, good, good. All right, the functions, modules, and packages encourage code reuse by breaking a large program into simple reusable pieces. The object-oriented nature of Python takes it one step further for grouping the components into objects. In fact, all Python files are modules that can be reused or imported into another Python program. This makes it easy to share programs between engineers and encourages code reuse. Python also has a batteries include Python also has a batteries included mantra, which means for everyday tasks you need not download any additional packages outside of the Python language itself. I do like the idea of that. I do really like the idea of that. Um yeah, I hadn't realized. Wait. To master Python and networking, learn regex, JSON, and some basic syntax. I personally like regex quite a bit, but that might be because I just haven't had to use it for something infuriating yet. Okay. Um, to achieve this goal without the code being too bloated, a set of Python modules, aka standard libraries. Oh, are libraries the same as Oh god, libraries are the same as modules. I didn't know that. Hey, 612 thank you for subscribing. All right, oriented equals polymorphism. An object can do or become different things. Inheritance, a child object can get properties from a parent. Encapsulation, an object has a clear purpose within its class. See, I like that. It sounds straightforward, object oriented. But I have no other reference personally because I haven't learned another language, so it's great. Um The joy of IPv6, every node has multiple addresses and they never know which one to use. I feel like you could port that what you just said over really well into like what's that? What's the where everything is made up and the points don't matter. Can't believe I forgot the name of the show. Anyway, that quote. Um let's get through this. Let's get through this. We can do this in 15 minutes. Let's go. Let's go. Ooh. Okay. Wake up. No more cozy. Okay. Ah. Yeah, okay. To achieve this goal without the code being too bloated, a set of Python modules, aka standard libraries, are installed when you install the Python interpreter. I have noticed this, yes. For common tasks such as regular expressions, mathematical functions, and JSON decoding, all you need is the import statement, and the interpreter will move those functions into your program. This batteries included mantra is what I consider the one of the killer features of the Python language. Absolutely. Sounds good to me. I have no qualms with that. Um, Lastly, the fact that Python code can start in a relatively small sized script with few lines of code and grow into a complete production system is convenient for network engineers. Emilio, 1213, thank you so much for subscribing. As many or sorry, following. There's a difference on Twitch, isn't there? I'm not charging money for this shit, so don't worry. Thank you for following. Yeah, lastly, blah, 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 blah. As many of us know, the network typically grows organically without a master plan. Yikes, it does though. A language that can grow with your network is invaluable. Okay. You might be surprised. Thanks. I don't know how to pronounce your name. NG. I know what it is, right? But I don't know how to say it. It's another one of the. Anyway, thank you for subscribing. The person who just did that. You've already been chatting with us, so thanks. Engine X. Thank you. Thank you, Nginx. I appreciate it. I think this stream, the real purpose of this stream just ended up being like me learning how to pronounce things. Okay. Okay, you might be surprised to see that a language deemed a scripting language by many is being used for whole production systems of many cutting edge companies. So there's actually, if you go to python.org, you can find a list of organizations using Python in that way. If you've ever worked in an environment where you have to switch between working on different vendor platforms, yes, service provider world, like Cisco iOS and Juniper Junos, you know how painful it is, yes, to switch between syntaxes and usage when trying to achieve the same task. Since Python is flexible enough for both small and large programs, there is no such dramatic context switching. It is just the same Python code from small to large. For the rest of the chapter, we'll take a high level tour of the Python language. If you're already familiar with the basics, feel free to quickly scan through it or skip ahead to chapter 2. That's honestly probably what we should have done with the networking section, but I wanted to make sure we got through like a decent chunk of that, and we got through all of it. So anyway, we are not going to quickly scan through the Python part of this, because this is the meat that I wanted to get to, right? Python versions. As many readers will already be aware, Python has been going through a transition from Python 2 to Python 3 for the last few years. Python 3 was released in 2008, over 10 years ago, with active development, with the most recent release of 3.10. Unfortunately, Python 3 is not backward compatible with Python 2. Yeah, that does suck. At the time of writing the fourth edition of this book in mid 2022, the Python community has all but moved over to Python 3. In fact, Python 2 officially entered end of life as of January 1st, 2020. The latest Python 2.x release, 2.7, was released over 6 years ago in mid 2010. Since Python 2 is end of life and is no longer maintained by the Python Software Foundation, we should all be using Python 3. In this book, we will be using the latest stable Python 3 release, Python 3.10. 3.10 has many exciting features such as stable asynchronous I/O that is very helpful in network automation. This book will use Python 3 for the code examples unless otherwise stated. Thank you, Hectic Maven, for following. When applicable, we will point out the Python 2 and Python 3 differences. That's very nice. I have encountered some issues already in my limited use of Python in my professional life between 3.8 and 3.10. And it's been quite annoying. And I don't really know. I don't really understand it. I just know I have problems using 3.10 in some scenarios, whereas I don't have those same problems if I'm using 3.8. baffling. But anyway, right, operating system. I think 2 hours is a good limit for me because my voice is starting to like bleh. So let me just say this right now, actually, before I keep going, because we've got a little less than somewhere around 10 minutes, right, to go. I'm gonna stop this at 7:30 my time, so after the 2-hour mark from when I started earlier. And we're obviously not, I don't think, gonna get through all of this. So I'm gonna do a second stream. I'm gonna do a follow-up stream, but I don't know when yet, so I will announce that, and I'll try to put it on Twitch. There's, I think, a way I can, like, schedule it and show it. I'll put that on Twitch once I decide. I will announce it on Twitter. I'll announce it on TikTok. And probably Mastodon, even though nobody cares about me on Mastodon. I'll post it in several different places, and I'll make sure that word gets around. If you're still interested, again, it will be me reading out of this book. Maybe I will be able to bring up like a command line and do some shit. Actually, um, we'll see. I'll try to make it a little more engaging, but it will be a lot of reading out of the book, just so you know. But in that stream, I do plan on. I don't know if I don't know if I'll announce the winners of the book giveaway there, or it's possible that the Art of Network Engineering actually may announce them on their Twitter account. So sorry for the lack of direction there, but I'm going to repeat this just in case we have new people, which I think we do. Um, so we're doing a giveaway of this book in conjunction with the Art of Network Engineering podcast and the author Eric Cho himself. And the way that you can enter this giveaway if you want to grab a copy of the book, I don't have my own Discord server, but the Discord server I exist on, I'll tell you that information in just a moment. Thanks for asking. Okay, so I'm going to put a link in the chat again. This is how you can enter for the giveaway. So if you click that link and you sign up, add your email, you'll have to go to your email and click on the invite link that you get once you do the initial sign up. Then you just enter in a little bit of information after you've clicked that activate link, and you'll be entered into the network automation community. This is just a little community that Eric Cho, the author, has started, and it's a place for it's a place for people to learn, share knowledge, go on this journey of network automation, learning it, especially surrounding the topic in this book, right? It's aimed at network engineers or people who want to know and learn about network automation specifically, right? Under that context surrounding this book. So if you would like to enter the giveaway for a copy of this book, a physical copy, go there, sign up, get in, enter in your information real quick, and then you'll see you have access to this dashboard, right, where Eric has posted some things. And I think he's got a post at the top right now that is like just talking about this live stream, going to do it. Just leave a comment in there somewhere, and you will probably use your email address to enter basically into a random drawing for people to get copies of this book. I don't remember exactly how many copies. It's more than one, might be two, might be three. I don't remember. So I'll get that information and post it. But anyway, yeah, if you're interested, please sign up for the community. It's designed to share knowledge and like keep people engaged in learning about network automation and talking about the content of this book and beyond. So take a look, even if you don't want to get into the giveaway. Like, I think it is worth looking in there. I'm on there. I haven't posted anything because I don't know anything yet, but I will definitely be participating. So anyway, there you go. Does Discord require a phone to register? Ooh, I do not remember. Like at first, I don't know. This isn't, by the way, the link I sent is not a Discord community. Sorry, it's an actual like website, like a forum. But anyway, okay. So let me post about the Discord. One sec. So, for those who are not familiar, I am a co host on a network engineering focused podcast. It's called The Art of Network Engineering, and it's on my mic flag. You can see that's our little symbol right there. It's called The Art of Network Engineering. You can find us on any popular podcatcher, right? Apple Podcast, Spotify, whatever. We don't go into like super in-depth, heavy technical stuff, but we do have a lot of conversations with like professionals in the network engineering space. We've talked DevOps before. We've talked network as a service. infrastructure as a service. Now I'm blanking on all the interesting things we've talked about. Of course, we've talked about Wi-Fi, although none of us are Wi-Fi experts. Um, we've done mental health episodes around being, mental health centered in tech. We've done a lot of stuff. We've talked to various professionals. We recently did one that I really enjoyed in particular about transitioning out of the military and into a technology based role. I was one of the hosts on that one. I loved talking to our guests about that. It was a great one. We've got a lot of varying different topics that I think are really engaging, honestly. So if you're interested in that kind of stuff, please listen to us. Okay, that's my spiel. Here, let me let me post the Discord invite. We have a Discord called It's All About the Journey. It is not just focused on the podcast. There's one channel in there for the podcast, but it's mostly for all of us who are in network engineering in some capacity to lift each other up, chat with each other. We've got a bunch of different channels. You can chat about all sorts of vendors, technologies, whatever you want. There's one for content creator. Yeah, anyway, we have like thousands of people in there now. It's a great community. Please consider joining if you're interested. I'm trying to find the invite now. God. It's been a minute. It's also on our website, theartofnetworkengineering.com. You can also find the invite there. It should be just like a. All right. Well, it looks like invites are disabled for the moment, so I'll ask about that. But I hope you should still be able to get to it. I'll post a link to theartofnetworkengineering.com instead. Um, I'm sorry about that. I don't know what's up with that. Hey, B7H30. I'm sorry. I hope I'm not like pronouncing it just like stupidly, but hey, good to see you. Thanks for popping in. I appreciate that. Oh, Mr. Hamill, thank you. See, I'm not even. God, you're so on top of it. You're the best mod. Thank you so much. See, I'm not looking at chat. I gotta get better at twitching. Gotta get better at streaming. Anyway, thanks, Mr. Hamill. Appreciate it. Anyway, okay. So if you're interested in network automation, please take a look at the link I posted earlier for Eric's community. And if you're interested in NetEng, take a look at our Discord server as well. I am there. I am not the most like talkative, but I definitely will respond if you summon me. Use that power wisely, however. Okay. All right. So that's enough shameless self-promotion. It's 7:25. I'm going to keep going cuz I really did want to get through at least a decent amount of the Python stuff. Let's see. Let's get through our hello world, okay? And then I'll stop it. And I will announce like when the follow-up stream is if you'd like to join me for that as well. Um again, if you follow the Art of NetEng on Twitter or just take a look at their Twitter here and there, they'll announce the winners of that giveaway. And they'll I think I'll have to let you know when that's going to be because we don't have a date yet for the announcement. You can see we're very organized about this, right? All right, operating system. Operating system. Um, as mentioned, Python is cross-platform. Python programs can be run on Windows, Mac, and Linux. In reality, certain care needs to be taken when you need to ensure cross-platform capabilities. My brain's just making up words. I'm sorry. That works though. Compatibilities, capabilities, it's the same. Okay. Certain care needs to be taken when you need to ensure cross platform compatibilities, such as taking care of the subtle differences between backslashes in Windows file names and the steps to activate Python virtual environments on different operating systems. Since this book is written for DevOps, systems, and network engineers, Linux is the preferred platform for the intended audience, especially in production. Fuck, so I'm going to have to get WSL running, aren't I? Fine, fine. You know what? Fine. I'll do it. Fine. The code in this book will be tested on Linux Ubuntu 22.04 LTS machines. As of this writing, Python 3.10.4 is the default version that ships with 22.04, so we don't need to install Python 3 separately. I will also try my best to make sure the code runs the same on the Windows and the Mac OS platform. Okay. So here he is showing our flavor and version. Okay. Running a Python program. Python programs are executed by an interpreter, which means the code is fed through this interpreter to be executed by the underlying operating system. There are several different implementations of the interpreter by the Python development community, such as IronPython and Jython. Sounds weird. In this book, we will use the most common Python interpreter today, CPython. Whenever we mention Python in this book, we refer to CPython unless otherwise indicated. Okay, sweet. You can get Python 3.10 for Windows and construct scripts using Visual Studio Code. That's what I do at work, except I don't construct them. But I got it. I've got it. WSL can work, but would add a few layers to the setup. Okay, thank you. So then maybe I will stick with my Windows shit for now and Visual Studio Code. We'll see. I'm not sure. That's something I think I want to ask Eric is like, can I do this without there being too much headache with following along with the book, right? And I do this on Windows with Visual Studio. Jython is the unholy marriage of Java and Python. Okay, that makes more sense why it's called Jython. Oh man. Okay. One way you can use Python is by taking advantage of the interactive prompt. Only glasses, thank you for following. Yay. This is useful when you want to quickly test a piece of Python code or concept without writing a whole program. This is typically done by simply typing in the Python 3 keyword. Yep, yep, yep. So you hop into like, I do know that, if you have things properly set up on Windows, you can open up like a command prompt and just type in Python or Python 3, depending on what PDN Duke. I think that's what your name was. Thank you for following. Good to see you. Yeah, so you can type in Python or Python 3 and it'll just bring you into, Python shell or whatever. The interactive mode is one of Python's most useful features. In the interactive shell, Dan Lozanoff, thank you for following. Holy shit. In the interactive shell, you can type any valid statement or sequence of statements and immediately get a result back. I typically use the interactive shell to explore a feature or library that I'm not familiar with. Okay. The interactive mode can also be used for more complex tasks like experimenting. Hat Knight, thank you for following. Like experimenting with data structure behaviors, for example, mutable versus immutable data types. I don't know what the fuck that is. Talk about instant gratification. Hey, it's our second exclamation mark in this book. Hooray. Amazing lecture. Yeah, it really is a lecture, right? I'm just reading out of a book, but a book written by somebody smarter than me. So hopefully you are actually learning. On Windows, if you don't get a Python shell prompt back, you might not have the program in your system search path. The latest Windows Python installation program provides a checkbox for adding Python to your system path. Make sure that it's checked during installation. Maybe I should just, I've already done this, but I could uninstall and reinstall Python on stream if that's helpful. I feel like most of my audience is already going to be so familiar with this, it would be useless, but who knows? Like, it's fine. I would definitely do that. Or you can add the program to the path manually by going to environment settings. I'll say this is the part, honestly and truly, when I was first was not familiar with any of this at all. Dog is licking my toes. When I was first learning about all this, was not familiar with programming at all, and I had to install Python. I was like, what the fuck am I doing? I don't understand this. And I definitely installed it without adding it to my path, the path, right? Didn't know to check that box. And then I had so many issues and didn't understand, and like I had to go get someone's help, and it was just so that was, I don't know, as a true beginner, that was one of the most annoying fucking things to deal with because I did not understand. I still don't know what a path really is, but I have a better concept of it. Like I couldn't tell you, but like I get it. I kind of get why you have to have it added to it anyway. And then I just transferred to a new laptop, so I had to all go through all of that again, and I finally sort of like understand what I need to do every time I fucking install Python. But anyway, Jesus Christ, it is annoying to do as a beginner. So maybe I'll just do a quick stream where I do that. Anyway, a more common way to run the Python program, however, is to save your Python file and run it via the interpreter after. This will save you from typing in the statements repeatedly. Python files are just regular text files, typically saved with a .py extension. In the Nix world, you can also add the shebang. Is that what that's called? shebang. You can also add the shebang line on top to specify the interpreter that will be used to run the file. That's cool. The hashtag character can be used to specify comments that will not be executed by the interpreter. The file hello-world.py has the following statements. And you can see we've got a hello world. Why won't you let me zoom in? Adobe? There we go. Hello world. Hey. So then you execute your file by saying Python and then file name. Boom. And then it does what you tell it to. Yay, we did it. We did our hello world. I didn't do it, but you know what? I will pick up here next stream and I'll actually go through the quick installation of Python 3.10, whatever. I'll check the box to add it to the path. And I'll write a little file. I'll write a little script that does the hello world, and then we can start moving on from this part. Does that sound good? I hope that sounds good. All right, I'm gonna catch up on chat real quick. INV or virtual NV? What book is this? Okay, Dan Lozano. Sorry to answer you in a very delayed fashion. Make sure no one has ever has answered you before. Anyway, it is the book Mastering Python Networking by Eric Cho. So let's see. Can I add a bookmark? Add Adobe. How do I add a bookmark? Whatever, I'll figure it out. So we're still in chapter 1 and we just hit Hello World. I think that's an easy place to remember. Started. We got through almost 20 pages. I'm proud of us. Dan Lozano. This is the book that we're in right now. And we're giving away a few copies. So and I'm going to sorry, I keep posting this link, but I just want to make sure everybody gets it. If you sign up there, it's a pretty quick, painless process. You have to go through a couple steps they're doing it to weed out like spam and shit. So just if you click there, you sign up with your email, go to your email, click on the activation link, and then you just enter in a little bit of basic information about yourself. You'll be in a like community dashboard where you'll see a post about this live stream. If you want to be entered into the giveaway for a physical copy of this book, leave a comment. Leave a comment on that post that Eric made about this live stream, and you'll be entered into the giveaway, and we'll pick randomly 2 or 3 people to get copies of this book. So anyway, this is what we're reading. So anyway, I think this is a good stopping point. We just got to Hello World. I'll make it a little bit more engaging next time. We'll do a little bit of Python. I think I can do it. I think I can do a little bit. Just a little bit. The Hello World, at least. So anyway, I want to thank you all for joining me. This has been really fun. I forgot how much fun it is, honestly, to stream and like chat with people. I really appreciate y'all coming in and like chatting and giving your experiences and asking questions. It's just wonderful. I love this community. All right, I'm gonna stop the recording now.